Hey everyone, Fusman coming at ya. I've mentioned several months ago at this point in my kind of NFT recap video that honestly don't see that much value in the current ecosystem of the Openseas and Raribles of the world, where fundamentally the value just pretty much comes from who signs a token and not really so much the actual content of the token. Moving into the future, I think there's a lot of opportunities for that. And really, I think that comes to adding a level of smartness to NFTs, which means being comfortable with writing custom NFTs. I think it's kind of the difference really between your just generic Nyan Cat NFT versus an Axie Infinity token, where it revolves around the breedability, it revolves around the genetics of that Axie Infinity. And while it's not necessarily custom yet, I think that's where you start to dive into some of the exciting components of NFTs and really being able to own it, modify it, and then sell that out to somebody. And that is where I think I get really excited about the whole ecosystem. So in this video, we're gonna be taking a look at exactly that, where we're going to be writing a very simple YouTube thumbnail NFT, but writing it in a custom way, not just something that you could just toss onto OpenSea. It's gonna be broken down into two parts here. So this first part is actually writing that smart contract, and it's really not that much code. So we'll break that down step by step. And then second part is getting that into Unity, being able to check, make sure that an account actually owns the NFT, and then if so, displaying that within your game view. If you're not subscribed, definitely make sure you are so you don't miss that second video. And broadly, if you do have any questions, you're more than welcome to leave those down in the comments below and head over to our Discord where you can chat with the rest of the community. Okay, here is the smart contract. And again, as I mentioned, well, we'll just go ahead and explain this step by step. I've used Remix, which I'll talk about really briefly, as our editor to create this and interact with the blockchain. And you can see here actually at the bottom, this is deployed on the Rinkeby and Ropsten test network. So you can see here, this is on Rinkeby actually. So this is just one example of that, where we have all of these different functions that are associated with our ERC-1155. Actually a slight variation of ERC-1155 token, but it just has all the basis of it, where you have a lot of different functions here and a lot of read and a lot of write options for customizing this blockchain in kind of a more robust manner. And we'll take a look at the contract and tokens in just a minute. And if you do Rinkeby, I think one of the interesting parts about the 1155 token is that you can also test that on OpenSea, for example, by just going to their testnets.opensea.io/assets, and you can put in the smart contract. For our specific case here, I'm not actually going to be using JSON just to save in terms of actually having to host anything. But if you do use kind of JSON and some of those standard metadata files that OpenSea typically does, and here's just kind of the documentation on what they typically look for and all of the standards associated with that. If you do that, that'll all pre-populate here. So you'll have an image, you'll have descriptions, you'll have properties that would then ultimately pop up on this page. But for the specific purposes here, quite frankly, I just stuck to a very simple scheme where you're just getting the image as your URI, and you don't have to worry about the JSON and storage of that, which I think really deserves its own separate video. So as I mentioned, this is based on the ERC-1155 standard, and at the start of any Remix and Solidity smart contract that you're building, you're typically going to be using some base file. So you can see here, we're building off of this preset function for 1155, and that's imported in from Zeppelin. So Zeppelin has a bunch of open source Solidity contracts that you can take a look at, and they're just available here at Zeppelin contracts. We're looking at the 1155. So the base here is the 1155, and this is a really amazing token standard. It has its flaws, which I'll talk about a little bit later, but it allows you to have a system that works for both fungible, so your ERC-20 tokens, and non-fungible tokens. And the way this works is fundamentally, as you can see right here at the beginning of the 1155, is just a map of balances that are associated with various different token IDs. So you have a integer, which represents the token ID. That's then mapped to another map, which contains, for a given token ID, what are all of the addresses associated there? And more specifically, for each of those addresses, what is the specific balance? So this is useful in contexts where maybe you have an NFT and it's just one balance. So then one address will map to just one, whoever actually owns that NFT. But if you want something more generic where you could have multiple people owning different tokens and it just being flexible in that regard, the balances really allow you to do that. So that's really the core concept, and it's basically the core data structure. It's a map that maps from ID to a set of addresses to the balances of each address. And then you have a wide set of functions. So you have your URI field, which represents the quote unquote metadata for your specific contract that is typically going to be stored off chain. You have the balances of that we talked about. And the nice, interesting part is you have some batch functions that make it very efficient to put in multiple transactions and save on gas fees when you're actually interacting with the blockchain, which ERC-20 and 721 didn't really have, where you typically have to run multiple transactions if you're dealing with different addresses or different tokens. So that's the building blocks of the ERC-1155. The specific token and contract that we are inheriting from for this video is actually this preset minter pause. So this provides kind of more of that production level quality and augmentation to the 1155 contract that is going to allow you to have different roles associated with the contract and allow you to be a little more dynamic as your contract is up in production. This is very useful for cases where you have a team working on a contract. You might want to make changes down the road based on someone joining your team and who needs, say, access, admin privileges, if you will. Someone might leave your team, etc., etc. This allows you to have some of that functionality as part of the contract so you can make it a little bit more dynamic at runtime. Because something to keep in mind is once a contract is deployed and it's in production, it's locked, it's immutable, it can't be changed unless you build in that functionality for yourself to make those changes possible. That's what we're working with. And that is where we are inheriting from. And that serves as the basis for our YouTube's token smart contract. So with 1155 explained, let's just kind of maybe walk through here. This is Remix. I'll leave a link to this down in the description below. It's a very fast and easy, clean editor to work with in the browser and has a lot of the setup already hooked in for you when it comes to developing Ethereum smart contracts. So you can set up a lot of tools locally on your machine, but if you are comfortable, like in the purposes of learning, like this video, you can leverage this web ecosystem really to develop smart contracts and get them deployed to the blockchain through MetaMask. So you'll get a workspace here, and in this specific case, I have an NFT.sol. So Sol is the extension, and you can create that within your workspace by simply creating a file and then naming it like this. So like NFT.sol. So this is our smart contract. The top, again, as usual, you just define which Ethereum compiler you want to be using. So we're going to be using 0.8 here. We talked about the import and we set up our smart contract. We have a couple parameters here for our specific purposes here. And the reason for these is to have a mapping between a human readable version of IDs and numbers that are specific to your NFT. So typically with a lot of these types of contracts, you have a system where it's just 0, 1, 2, 3, 4, 5 are IDs associated with NFTs, and then you can use them to get the specific data for that specific NFT. In our case, we want to use something a little bit more human readable, and actually more specifically, when we're dealing with, say, YouTube videos and YouTube thumbnails, they all have IDs that are associated with them. Even if you look at this video in and of itself, it has a small short hex ID that you can leverage. And so the idea here is to actually use that ID as a base for our specific URLs that we're generating as part of this NFT. So that's why we have this here, is to, one, save how many NFTs have been added to the smart contract. Two, to have a map that swaps in between the YouTube IDs and our NFT IDs. Then we have our constructor here, and we just pass in the prefix to our URL that we want to create. The three functions that we have here below are really kind of then what allows us to more easily interact with our NFT smart contract. And these are the things that I was talking about when it comes to adding in that smart functionality. And while this is very simple, it allows you to start thinking about ways that you can start making a lot of this more complicated and more interesting, if you will. So the first function here is just a very simple way to add a YouTube video into your NFT collection. So the way this works is you have just one function. It takes in the ID. In this case, I was playing around with the idea of a game. I switched this off to YouTube, so that's why it's a game ID. And then you set up a supply. So if you're working with NFTs, the supply in the context of ERC-1155 is always 1. If the reason for that, because 1 means that it's non-fungible. Anything more than that technically means you have an excess supply, just like dollar bills, and then all of those tokens are technically fungible in that regard. This gets really confusing in the current NFT ecosystem, but for very simplistic standards and kind of to differentiate it, 1 is non-fungible, more than 1 is fungible. This is our smart contract that allows us to go ahead and write to the blockchain and create our NFTs. So in this context here, what we're saying is that whoever calls the function add game ID, we're going to require that they have the minter role. So the minter role, as I mentioned before, is kind of coming from this production standard for the ERC-1155. You can find out more specifically about like how to set that up. There are a lot of different functions for that. But for our purposes, we're just going to check, are they a minter? If so, great, we can continue. Second thing that we're checking is for the ID, the YouTube ID that has been inputted into this, does that exist within our map? If so, we need to stop this function because it already exists at this point. If both of those checks pass, then we're going to actually go ahead and run the rest of the function. So we're going to create our incrementer counter so that we get a fresh index. We then are going to save the mapping for the YouTube ID to our internal NFT ID. Similarly, we do the reverse here with our lookup map and ID maps. And then there's an internal mint function that we call where we're saying mint that NFT for the person who initiated the smart contract call to add game ID. And then we pass in the ID, the supply, and we can pass in any metadata. In this case, it really doesn't matter. So that's how this works to start looking at some very simple smart contract functionality where you are combining the IDs and just having a mapping from external IDs to internal IDs. Next, we have our URI field. So the URI field is a built-in function for ERC-1155. In this case, we're overriding that functionality where given the ID for a smart contract token, we output a URL that represents where you can get metadata associated with that. In this case, YouTube has provided an API where at this image YouTube VI URL, you can actually go ahead and search for thumbnails associated with a specific video. So in this case, we're just creating a string where we have that base URL paired with the YouTube ID that has been inputted, if that exists. And then we add in this HQ default.jpg, which happens to represent the actual image that might be deployed on YouTube servers. So typically here you would provide JSON, and as we mentioned earlier, if you're using Opensea, you typically would want to point to a JSON file so that Opensea can read that JSON file. In our case, again, we're not going to be worrying about that much because anyway, we're in control of the smart contract. We don't really care about the Opensea aspect of things. We're using it for our own custom purposes for this NFT. And then finally, I've added in this get all tokens for the smart contract. And this is the part where I feel like the ERC standards kind of fail a little bit. typically for get all tokens, and we'll talk about this and maybe in a future video, for a given address, you want to be able to get all of the NFTs that are associated with that. And especially in the context of the ERC-1155, I think not having a get all tokens for a given address is a little bit unfortunate. The way that this is implemented is because we have a counter that's keeping track and adding IDs to us, that allows us to determine all of the tokens that have been added to our smart contract. And as a read-only function, this is a free call that you can make externally that can be very fast in this regard. So we can be a little bit flexible in how we write it, and I'll be honest, this is probably not the most performant way to do it, but it works. First, we loop through and check for a given address how many tokens are owned by that address. So then we can sum that up really quickly and just check and make sure that these are the sets of tokens that are needed to be added to our array that we ultimately return as here are the token IDs that this address owns. Next, we then have to create a return array at this fixed length, which is the number of tokens, which is why we have to do this first for loop in the first place, as there's no way to dynamically add to an array that I'm aware of. If there is a way, let me know down in the comments below. But the second loop basically will go through and say, okay, now that we know how many tokens are owned by this person, let's go ahead and create an array of that fixed length, and then start assigning all of the IDs that would be required to create this actual array for that represents all of the tokens that are owned by a given user. And then we can return that array, and then you get a nice clean array of all of these token IDs that the actual address owns for this specific smart contract. That's an extremely useful function that you have to write yourself, as it's not part of the standards. And in part, it does require some of this base setup of like having a game ID counter, which is not part of ERC-1155 and the like, but it makes your game logic when you get to Unity so much easier than having to go through a lot of loops and hurdles that you would ultimately have to go through in order to determine what are the available NFTs for a given address. So with these three functions and with our constructor set up here, this forms the blocks for creating an NFT for YouTube thumbnails and being able to add them dynamically at runtime to this smart contract. And then using the Remix controller here, we can then compile against, we're using 08, so we'll use that compiler. In this case, it's been auto-compiled for NFT.sol and it looks good to go. Then heading over to our deployments here, you can then use the injected Web3, which will then look into your MetaMask and then determine how to deploy that. In this case, it's picked out my current address, and at that point, you can just go ahead and click deploy. There's nothing fancy here. In fact, we've already gone ahead and deployed that token here, but if we want, we can go ahead and do that again. Let's just go ahead and click deploy. That creates this Ethereum smart contract. You click confirm, and that will go ahead and save that on Rinkeby. So you give that a few seconds for that to get processed on Rinkeby, and once that does, it'll appear here in your deployed smart contracts, which you can see right here. Here's where it happened. So now, using this interface, we can actually start interacting with our smart contracts. So for example, I'm gonna go ahead and pull up this YouTube video here. Let's go ahead, grab the ID for the video. I'm gonna go ahead and paste that in, and we're gonna create this as an NFT with a supply of 1. I'll go ahead, transact using that interface, and then we'll confirm. That's gonna go ahead and add this to my wallet as an NFT that is connected to this ERC-1155. And once that happens, and we'll give that a second. There you go. Let's first check here that this is available on Rinkeby. And you can see just like that, we have our deployment contract, and then we have our actual interaction with the blockchain. And then if I go to Opensea, I'm just gonna go ahead and replace this right here with the smart contract address and game ID of 1, because that was the first thing that we created. And you can see that that has come in successfully. There's my smart contract public key so that we know that that's working. And this just proves that this is actually created an NFT that is readable by Opensea, even if there's no JSON that's actually associated with that. And that provides kind of the framework for you to start building out custom ERC-1155s. If you have JSON associated with that, great. That'll then get pulled into Opensea, and you have this framework for testing and iterating here. And just to make sure we're all good in all the regards, right? So we can see the game ID counter has been set to 1. For my address, so if I go ahead and copy that, and then we head back down to get all tokens, I'll go ahead and paste my address in. You can see that the array that was returned here has the index of 1 associated with that. And for our URIs, for token 1, ID 1, I'll get that URL that is associated with my actual YouTube thumbnail. So now if I go ahead and copy that, I can paste that into a browser here. Here's the thumbnail that's associated with that. So all of that is now functions that are available on the blockchain. In our next video, we'll take a look at taking this actual smart contract, getting the ABI, then going and deploying that into Unity and being able to get the URL, and then being able to, with that URL, download the image into Unity and to view that as a texture. So if you're interested in that, make sure you're subscribed so that you don't miss it, and then I'll catch you in the next one. This has been Fuse Man, and I'm signing out.